Hello there, students from Behave School. This is Teacher Krishna, and welcome to our science class for the week number 13. And before we start, I would like to thank you all for all of the effort that you have put into entering our online lessons and to completing all of the assignments that we have given you towards this week's. So keep up the great effort that you're doing, and I'm pretty sure that with a little bit more time, you will be doing even better than so far. Okay? So, with that being said, let's continue with some general instructions before we start. Log into Agilix, enter the Google Classroom, download the Word document, and name it in the following way. That is very important. The only difference from this week is that you need to add week number 13 at the beginning. Then the rest of the information is pretty much the same. Okay, and as we move, remember to take notes on your Word document because that is going to help you out to keep track of the most important information from this video. And remember that it's always important to start with our end in mind. So for this week, it's the following. Describes the measurable properties of electromagnetic radiation by describing the properties of waves, so that he or she can describe how light is used to measure distances in space and complete the week assessment. So I know it's a little bit long, but do not worry, we're going to break down all of this ending minds towards the following parts of the presentation. So you can have a clearer understanding of what this is trying to communicate. And this is the first thing that you need to write down on your Word document, so make sure to write it down. Okay, so the topic we're going to study this week is light and the universe. So, there are some important terms that we have to analyze before we start with everything. The first one is wavelength, and it is the distance between the highest or lowest parts of a wave. So do not worry, I'm going to show you in a picture just in a while. And we also have to analyze electromagnetic spectrum, the full range of electromagnetic radiation. So this is a wavelength. So as you can notice, the parts that are signalized in the picture are the highest parts from the wave. But you could also measure the wavelength from the lowest parts of the wave. And now here I have another example for electromagnetic spectrum. So pretty much what an electromagnetic spectrum is how frequent the waves are. And just like you can notice here in the picture, we have different images. For example, we have the sunlight right in the middle. So that very small part from line to line is the visible light that we can see with our naked eyes. But there are other type of waves. For example, if we go to X-rays, that we are not able to see those waves with our naked eyes, but we are sure that they exist. As well as we go with a radio waves, for example, on the left, they exist, but it's not something that we can actually see just with our naked eyes, just like I mentioned before. Okay, so continuing, we're going to be studying a little bit of astronomy as well. So astronomy is the study of all the parts of the universe. So stars are just a minimum part of the things in the universe. So, and of course, when we talk about astronomy, we might think that it's mainly the study of stars, like the study of constellations and where and how we can identify them. But in reality, that is just one part that astronomy studies, because it's going to study absolutely everything in space. So, you have to notice that the universe contains all matter and energy. So, when we include those main topics, trust me that we have a lot to study. We have stars, we have light, planets, asteroids, galaxies, dust, and etc. So, because of the definitions, we're going to be defining them a little bit. I'm pretty sure that we're going to have them clear. So, first of all, we have stars. So stars are pretty much an aggregation of gases that are constantly changing their composition somehow. So when they change the composition through something that is called a fusion, then fusion and fission, they start creating light, and that's how it is possible for us to observe light from incredible distances around the space. We also have planets. Planets are an aggregation of solid material, such as rocks, as we can see it in our planet Earth. Our planet is mainly composed of solid materials like rocks, but there are other planets that are just composed by gas. So, for example, if we talk about some of the last planets of our solar system, they are mainly made of gases. Okay, and if we talk about galaxies, we can say that they are a huge composition of planets, asteroids, and stars that are rotating around an epicenter that is usually made by a black hole. Okay, so let's continue, and we're going to talk a little bit about light as well. So light is a form of energy that travels through space as a wave and a particle, or a photon. So a photon is a particle that travels in the shape of waves that produces radiation. And propagation is the start of a disturbance. So here we have an example of what a photon looks like. So pretty much it has the shape of a wave. That is something that we had analyzed before. And this is the direction or the way light travels around the universe. And we're going to see it a little bit later on, but light can travel through something called a vacuum, which is a space where matter is almost non-existent. That is pretty impressive. And in order to compare it, we have some parts of a wave. We're going to start with the amplitude. So you can notice that there is like a line that is crossing right in the middle of the wave. So from that middle line to the highest part of the wave is what we are going to call the amplitude. Wavelength is something we already analyzed, and it's basically the measure between the highest or lowest parts of the wave. We find the equilibrium, which is the part in which the wave passes through that middle point that is kind of slicing the total wave. We have the crest, which is pretty much the top of the wave. We have the through, which is the bottom part of the wave. And lastly, we have the frequency. The frequency is basically how many waves there will pass in a certain time. For example, here we can say that there are a total of 3 waves, for example. But if there are more waves, the frequency will be higher. For example, 5 waves, 6 waves, 10 waves, etc. Okay, and here we have another example of what wavelength is. You can notice that in the top image has a higher wavelength than the one that is at the bottom, because there is a difference in the frequency of the waves. And here we have the frequency, which is what I was telling you about. A lower frequency, you can notice that is a higher undulation around the image that we have right there. And a higher frequency are like way more inconstant curves around the graphic. Again, and here we have something very interesting to analyze. So if we have a shorter wavelength plus a higher frequency, we're going to have a higher amount of energy, just like you can see in the example right there. So one of the girls is quickly moving the jumping rope in order to generate this high energy with short wavelength and a high frequency. On the other way around, if we have a longer wavelength plus a lower frequency, of course we're going to have lower energy. One more time in the example, the girl is moving the jumping rope in a certain way to create a longer wavelengths and a lower frequency. And if we analyze this example, it's pretty much obvious where it will require more energy to produce those waves. And we'll be in the first example, the one that is at the top, because you need to move your hand quicker to the top and to the bottom in order to produce these waves. Okay. Now we're going to talk about a longitudinal wave and transverse wave. So here I have an explanatory image for both of them. So you can notice that in the transfer wave, and we have, let's call them like two types of waves. One that is going up and down, but in between that motion of up and down, we have like a double motion, let's call it like that. Because if we move it like quite fast, then even though the material is going up and down, in between that movement, we're going to have faster and littler waves that are going to be produced in the material. But now, if we go to the other one, a longitudinal wave, you can notice that the whole material is not going up and down, like it is just following one certain direction. And even though there are different waves that are being produced in there, and we cannot see that it changes direction somehow. That is the difference between longitudinal wave and transverse wave. Now, we're going to analyze sound and light waves. So they both travel in waves. And you have to notice that sound travels through the compression of air particles or other substances. So, well, right now you're listening to me, but it is only possible because the particles of air are being compressed. So that's something really interesting to analyze, because in our daily lives we perceive different sounds around, but we do not really think that it's because of the vibration of particles in air, but they are produced in that way. But light travels in a vacuum. Do you remember what vacuum is? I mentioned it before. Oh, I'm sorry. So pretty much vacuum is a space where matter is almost invisible or non-existent. But even though in that way light can travel in that way. Here is another definition. It is a volume where matter is mostly absent. And here is something very interesting. Let's imagine that you go to space and you see an explosion. So do you think it's possible to listen to the sound produced by that explosion? Well, in reality, it will not be possible, because in order for sound to move around, it needs a source to be transported by. For example, if we talk about Earth, and what is the source that facilitates sounds to travel around? It's air. But in space, there is mostly vacuum, in which there is not a clear substance or thing that is going to facilitate the sound to travel through space. So probably you're able to see the explosion, but you wouldn't be able to listen to anything. And there is a misconception of this concept in science fiction movies, because you can actually see in science fiction movies that there are great explosions and that the travelers can listen to everything that is going on. But in reality, if you go to space, that will not happen in that way. Alright, so we are going to go to our evaluation. So read pages 4 and 5 from topic 4.01. So I already summarized most of the content that is in the topic that we're studying today, but I still need you to read a little bit more, pages 4 and 5, to complement your summary. So once you are done, complete the assessment from topic 4.01. And keep in mind that this evaluation is 10 points. So make sure to study and read carefully all of the topic before you take the evaluation. Right, guys, so with that being said, this is our class for the week. And I really hope that you are staying safe at home. Remember, if it's not extremely necessary to go out, stay at home. It's for your own health and it's for everyone's health. So if you have any questions, you can just let me know in the Google Classroom or in the Zoom session that we're going to have later on. So a pleasure to have you here with me today. I will see you next week, guys. Goodbye.